About myself, my name is James Bowen. I'm a graduate chemical engineer with a PhD in chemistry, both obtained at the University of Birmingham. My speciality is in nanomaterials and surface chemistry, and I currently run a laboratory in the chemical engineering department which engages local industry. The aim of my research, for myself, it's to understand intermolecular forces and the processes which go on at interfaces between materials. In my dual role as facilities manager for the Advanced Materials Laboratory, we engage local and national business and try to offer short-term solutions to industrial problems. The equipment I maintain and work with helps to characterise systems that would be useful to industrial applications. For example, understanding the mechanical properties of encapsulated materials when they're formulated into a tablet, for example. Furthermore, understanding touch and sensory properties of perhaps a smartphone surface would require detailed characterization of the mechanical properties and surface topography of the smartphone screen. The equipment we most often use would be a profilometer, an optical profilometer, which uses reflected light and the interference pattern generated from that reflected light in order to create a 3D structure of a surface profile. The atomic force microscope, which is a very powerful technique which allows one to resolve structures of surfaces and materials below the diffraction limit of light. So where you cannot get information on perhaps molecular shape and even atomic structure, one can use an atomic force microscope to determine these kinds of details. Fundamental principles that we use in the laboratory include, for reaction engineering, we can study the porosity and tortuosity of porous materials such as reaction catalysts or supports. Further, we can study the mass transfer of materials. So, for example, we can look at the moisture uptake and desorption of materials by exposing them to certain humidities and temperatures and monitor the change in mass as a function of time. So we have a rheometer, and we can use that for measuring the properties such as viscosity of Newtonian materials, but beyond that we can also measure shear rate dependent behaviour of non-Newtonian materials, perhaps viscoelastic polymers or particle suspensions in which they exhibit shear thickening behaviour. We can make a relevance of this information to topics such as mixing, where fluids are put into combination and the shear stresses they're exposed to determine their final formulation property.